Hi, my name is Brian Gren, and this is the second video in a series that I'm doing on how to manage the Oracle ZFS appliance in OCI. In the first video, I walked through how to go through the installation process to create the instance. This video, I'm going to go through how to manage storage. It comes with default storage when you go through the marketplace, but you may just use the image, or you may want to add more storage later, or you may be interested in just how, the back-end storage works. That's what I'm going to talk about today. Just to do a quick overview, the ZFS and OCI attaches block storage that is iSCSI attached. It has to go through the service gateway, and you can attach multiple block volumes. Those become the storage pool. And just like a ZFS appliance on premise, you create projects and shares that are members of that pool. You can create multiple pools. So first, a little bit about myself. I blog at briangren.blogspot.com. I'm a database specialist here at Oracle, and I work a lot with ZFS, especially around the database. So what I'm going to talk about today, this is the second part in the series. As I said, the first part was creating the image itself in OCI and getting started. This presentation is going to be on storage, and the next one I'm going to do is going to be more on networking. So the steps to add storage. The first thing that you need to do is to decide on the size of the block storage device. You create the block storage devices, you add those storage devices to a volume group so that they're grouped together, and it'll help you with the management. You attach the block devices to ZFS. There's a workflow that will walk through the attaching of the device to the appliance, and then you create a storage pool from attached storage. Those are the high level steps. First, I'm going to talk about the first thing, decide on the size of block storage devices. So what you have to think about when you decide on the size of the block storage devices is how are you going to grow if you wanted to add more storage? You can have multiple devices, block storage devices, but when you want to grow storage, you're going to add another device of that same size. So let's say that I create a storage pool of 5 block storage devices. They are all 1 terabyte. I have 5 terabytes available in my pool. When I want to add storage, I'm going to add another block storage device of 1 terabyte, and I will have 6 terabytes. So that's the first thing you need to think about, is at what increment do you want to increase storage based on what you think the growth pattern is going to be and how much storage you need as a starting point. Second thing is IOPS and throughput of the storage is dependent on the size of the block storage device. So I'm going to talk a little bit more about that. So in talking about throughputs, I put together a chart where you can see that the block storage has VPUs. VPUs are volume performance units. So not only do you decide the size of each block storage volume, but you also decide on what the performance is going to be. By default, the performance is a balanced level. That's what you will see in the UI. It's a VPU of 10, and those are the numbers that you get per volume. And what I came up with is a chart on the bottom where you can see how that maps to the IOPS per gigabytes of storage, and how that maps to the throughput also. And what you will see is that there is a certain point with the size of the devices where they max out. And you can see that on IOPS, and you can see that on throughput. That's where those lines start to go flat. So on the right-hand side, especially looking at throughput, you could see where the low cost, the performance keeps increasing as the volume gets larger and larger, but it's typically lower than the other two VPU units that you would choose. And then when you look at balanced at about 1 terabyte, the balance maxes out, and that's all you're going to get is the 500 megabytes per second, regardless of how much bigger you make that block storage device. And with the higher throughput, you can see it goes up a little bit higher than the balanced. It goes up to about 700, and it maxes out at somewhere around 1200, at about 1200 gigabytes. So about 1.2 terabytes, you'll see that that maxes out. So that, this chart gives you something to think about and what you want to do with the block volume devices. And what you can do is combine multiple block volume devices to get more throughput. So if you look at the chart and you think about, throughput and IOPS and where those numbers are, if I have one device that is 5 terabytes, like I had in my example, I'm only going to see, for balanced, a throughput number of 500 megabytes per second. But if I take 5 1 terabyte volumes, I'm going to have 2,500 megabytes per second. So you can see where adding volumes that are smaller rather than choosing one single large volume can help give you more throughput, help give you more IOPS, and help control the increment that you are adding storage. So to move on, the next thing you need to think about is the price of block storage is dependent on the performance level chosen. So in the previous slide, I talked about the VPUs and how the size of the block storage and that VPU number affects the throughput and the IOPS, and it also affects the price. So if you take a look at the block storage pricing, so the volume has a cost itself, and that is 0.0255 gigabytes per month, or cents per gigabyte per month. And then the VPUs are charged on top of that. So the block storage is often a combination of the size of the storage plus the performance charge that is also, based on the gigabytes of storage that you're using. So you can see on the chart here that a lower cost VPU block storage is no additional charge on top of the price that you're paying for the base storage. And you can see when you go to higher performance, you'll get more throughput, more IOPS, but also the cost goes way up. And what I calculated out on the right-hand side is the total cost per month. So you can see for basic block storage with lower performance, it's $25 per terabyte per month. When you get up to the higher performance, it's $61 per terabyte per month. So that is definitely something you want to balance and something that you want to think about, especially if it's a replicated copy. Then maybe it is lower performance is, good enough for what you're using it for, but the ZFS that is providing the active mounts could be the higher performance or the balanced performance. And there are high levels that are higher than that 20 VPUs, which is considered ultra high performance, but that requires multi-pathing. Multi-pathing isn't currently supported. And the last thing I'm going to look at is the storage throughput. And you need to know that it is throttled based on the VNIC bandwidth available by shape. So on the next slide, I went through a chart, and if you look in the documentation, it will tell you that a VNIC will, actually it's the shape itself. It's not just that single VNIC. All the VNICs have a maximum of 1 gigabyte per second for each OCPU that you have attached to it, up to 40 OCPUs. You can have up to 24 VNICs. There is 1 VNIC per OCPU, and bare metal will provide 50 gigabytes per second. So for a production instance, you may look at bare metal. That's a recommendation because that's where you're going to get the maximum throughput based on the VNIC. For a non-prod, or if you want to choose fewer CPUs, you'll see that there really is throttling that happens. So if you choose, let's say, 4 OCPUs, you'll find that you're only going to be able to get 4 gigabytes per second for that instance, regardless of the throughput of the storage that you chose. So if you think about what I went through in the last couple of slides, where there are throttles and limits that come into play based on the OCPUs, which you see here, the VPUs that you choose, and the size of the volume. So you put all that together and decide where you're going to get the performance that you need at a cost that makes sense. Because if you start adding higher performance, but your throughput limits are throttled on the VNICs, there really is no point of going to a higher VPU block storage. So you need to take a look at all those pieces and balance it out so that the cost makes sense and you're not overpaying for something that you're really not using. So back to my steps to add storage. I kind of went through what you need to think about when you decide on the block storage devices that you want to use. And it also is dependent on the size of or the shape that you choose for the ZFS appliance itself and how much throughput the VNICs are capable of, and match that to the storage that you're going to attach to it. So now I'm going to go through a demo going through these different steps. So first decide, and then create the block storage devices, and that's where I'm going to start. I'm in my OCI console now. I'm starting in the home, and I'm going to go under storage, block volumes. The Z cluster compartment is one that is recommended as part of doing the marketplace image. And you can see that I have created some ZFS appliances also, and you can see that the volumes that were already created. Because there are so many volumes out here, you should really, when you choose the name for the volume, match it to the instance, which will help you organize the volumes and what they are attached to. On here, just to point out, is under these volume names, you can see the sizes that I chose, the VPUs that are available. Some of these I do have 0 because they are a replicated copy, and other information about these block volumes. So now I'm going to create a new block volume. I'm going to call this demo volume 1. And this is where you make the decision on what you want to do for size and performance. You can see the default size is 1 terabyte, and it is balanced. Because I'm just using this ZFS image to do some testing for, maybe demo some of the capabilities of file retention, I'm going to do custom. 1 terabyte is fine, but I am going to change it to a lower VPU. And down here, it also tells me, the IOPS that I'm going to get and the throughput that I would expect from a 0 VPU. So as I go up to 10, you can see that the throughput goes up. And you can see as I move through ultra high performance, you definitely can increase the throughput available, but that's where you need to have multipathing in order to reach that performance level. So if I leave it on 20, another thing to point out is you can see the IOPS 50,000, 614 megabytes. So now I'm going to go to 5 terabytes. And you see that the IOPS did not change. The throughput is 680 megabytes. I go down to 4 terabytes. It still didn't change the IOPS on throughput. So you can see where there is a maximum IOPS and throughput that you're going to get even as you increase the volume size. So going back to having 1 terabyte volumes is going to give me more IOPS and more throughput than a single 5 terabyte volume. So I'm going to create the first one. Copy this to make it easier. It's provisioning. Creating volume 2. And I'm going to pause it and I'm going to create 5 volumes here. Okay, to go back to my screen here, you can see that I created demo underscore volume 1 through 5. They're all 1 terabyte volumes, and I chose default performance of 0. And actually, I need to correct this here. One of the nice things about the block volumes is that you can dynamically change the performance. So I made a mistake. I made it 20 VPUs. I wanted to have 0 VPUs. I just come in here and I edit and change it to 0, save it, and it will, underneath the covers, within about 60 seconds, change the performance from 20 to 0. And you can see where the advantage of doing that is, like I mentioned, is this may be used for a replicated downstream copy, where a VPU of 0 is fine when I am just replicating to it. It's not actively being written to other than the replication that it's receiving. Then if I do a switch over, this becomes my primary. I can go out to the volumes, change the volume to 20, and within 60 seconds, all my volumes will be 20 and I'm going to get the performance that I need. So I only pay for that increased performance when I really need it. And when it's just the replicated copy, it can be a lower level performance. So going back to my block volumes, here they are, volumes 1 through 5. And you can see that my default performance is now 0 for all of them. We are now on the third step, and the third step that I recommend is adding the block storage devices to a volume group to help with management. This isn't necessary, but it does make it easier as a group if you wanted to, control what they are attached to and view it as that group level rather than as individual block storage devices. I'm back here to where we were looking at the block volumes, and on the left-hand side, you can see where there are volume groups. I already have a couple. I'm going to create a new one here. Demo volumes. Create the availability domain. And then I add the volumes to it. Volume 1. You can see where this is pretty quick here. So these demo volumes, 5 demo volumes, are all part of this demo group. At this point, I could set up cross-region replication if I wanted to do that. Since this is a ZFS, it is best to have the ZFS handle the replication rather than to replicate the block storage devices. And then I can do backup policies if I wanted to. The recommendation is to do the backup A share to object storage through the cloud interface, cloud backup interface on the ZFS itself. So now you can see I'm taking these 5 block volumes and I am adding it to a volume group. And here is my volume group. The next step is to attach the block devices to the ZFS instance. I'm back here in the OCI console. So from the volume groups, I'm going to go over here and I am going to go to my instances. I'm going to choose my instance. I'm going to have to start it here before we finish attaching it. And I'm going to add these volumes. I already have a couple attached. So I go down here under attached block volumes and I want to attach new volumes. So make sure that I choose the correct compartment and I'm going to attach them. I can just leave the defaults. It will choose iSCSI, which is how they're going to get attached, and by default they are read-write. Okay, let me pause this, start up the instance so that I can attach these. Now that my instance is running, let me try this again. Attach block volume, demo volume 1, 2, 3, 4, and 5. So now that I attached the volumes, I'm going to go to my ZFS appliance. Now I've logged into the ZFS appliance, and where I want to go is the workflows under maintenance. So when I look under workflows, there's 3 workflows here that I use to manage the attached block devices in OCI. Attach is the one I'm going to be using. If you want to detach storage because you later, want to remove those block volumes, you would use the detach, and the list just gives you a list of the targets so that you can see what they are. If you go to detach it, it might make it easier to find those names. So when I click on this execute workflow for attach, you can see that it's asking me for these 2 parameters, the port and the IQN. In order to attach these 5 devices, I'm going to go back here. And when I look at these volumes and I go under this iSCSI command and information, expand out the Linux, it gives me the commands that I need to attach the block devices. What I really need are these 2 pieces here, and there's a nice little copy button. So if I go to the IP address and port, copy that piece of it, go over to my ZFS image and paste it, go back here to the IQN, copy it and paste it and apply. I'm waiting and it should successfully attach that storage. So it gives me a screen back that tells me that this is the target that it was able to attach. So I'm going to pause it and I'm going to attach the 4 other devices in the same manner. I have now gone through attaching all 5 devices in that same manner. So I have those 5 block devices attached to my ZFS appliance image in OCI. So the next thing I want to do is create a storage pool that is based on those block volumes. And then from there, it will look just like a regular ZFS with storage attached. So I go back to configuration, storage. I already have a pull. I'm going to add a demo 2 pull. And on here, I can see that I have 5 devices, a total of 5 terabytes. The model is OCI, so it does know that this is an OCI image. And I'm going to make those striped. The choices that you get on this screen are dependent on how many disks. And the thing to think about is that unlike on-premise storage, since this is in OCI, it is already mirrored, it is already highly redundant. So you really don't need to have stripe or, any of the normal pull configurations that you would use to have mirroring or Z-pull or anything like that, because it is already mirrored underneath the covers, and that will just degrade performance because it's going to be doing multiple writes. So this is, all you really need is normal redundant or no redundancy on this, and then I'm going to get full use of the 5 TB, and then commit it. Didn't like me creating 2 storage pools, but there we go. So I have demo 2. And as you can see, as I went through the demo, I've got 5 1 TB devices. If I wanted to make it 6 TB, I would just go through the same process. I would add the device, and then on here, I would say add. I would see that there was a device. I would choose a device. I would commit it, and then that device would be added to the, the pool. So that's all there really is to adding iSCSI devices, those black devices, to the ZFS appliance to give you storage. And as I went through, you can see why it's important to make correct, good decisions on both the size of the volume that you're going to use and the VPUs. The VPUs can be adjusted. The size you can't really adjust on it. So that you really need to make the decision up front. So typically 1 TB seems to make sense to me, and then multiple volumes of that 1 TB, because then you're going to get the increased IOPS and throughput, because soon after that 1 TB is the point where you don't see an increase in IOPS and throughput. Hopefully that's enough information to get you started and start attaching storage and working with the storage that you attach to the ZFS image in OCI. And thank you for listening.